Okay, so let's continue with our equal fraction method, over equals over. And let's apply it to a real life shape. So if I draw the shape in our notes, obviously not to scale whatsoever, and I label the lengths of this shape. Now, these are obvious lengths. 12 is the vertical big one, x is the vertical, and 4 is that one. Now, if I put 8 right here, it's almost obvious what that is. It is the whole length from here to here. So the first thing that I'm going to do is I'm going to draw two separate shapes completely in exactly the same orientation. Now keep in mind, this doesn't have to be perfect. They're not obviously going to be exactly, but it's just going to help me visualize. So the big one is 12 and 8, and the small one is x and 4. Now you may have already figured out in your head, we want to do more difficult problems. So we're going to be working through very simple problems, and we're going to be applying them to a much more difficult state. So we're going to start with the method in the center of the notes. Feel free to watch the note, read through the notes, print them, whichever you like. X over 12, should have started off with over equals over, is 4 over 8. So the way I set that up was I set it up as small vertical is to big vertical, as small horizontal is to big horizontal. But you can set it up any way you like. You just have to be respectively. So for example, I could set up 12 over 8 equals x over 4, or x over 12 equals 4 over 8, or 8 over 4 equals 12 over x, or x over 4 equals 12 over 8. There's all types of examples that we can set that up with. But outside of that, I chose that one. So I'm going to say, how do I get from 8 to 12? And if you'd like, you can take your calculator out and remember from the last one, bigger divided by smaller, 12 divided by 8 is 1.5. And if I'm going from 8 to 12, I know I'm getting bigger, so it's times 1.5. Now, if I'm multiplying the bottom by 1.5 and I want to go in the same direction, we do the same operation. And then you can either do long multiplication or take your calculator out again and do 4 times 1.5, and we get 6. So I can say x is 6. I can just say 6 equals exactly where x is, and then I can circle it. I can obviously rewrite it somewhere else, but this is the simplest way. Now, again, as you can see in the notes, I could have set this up as ratios. So, for example, we know 12 is to x, big vertical is to small vertical, as 8 big horizontal is to small horizontal. And again, that works exactly the same situation as over equals over, and you can do to the left as you did to the right, or do to the top as you did to the bottom, etc. And in the last page, we used do to the top as you did to the bottom and all the other examples. And we also showed the lowest common denominator example, which we're going to see later in equations. But I always like to throw a few little other methods while we're going through this, because you might find that easier. So let's do x over 12 equals 4 over 8, exactly the same setup. Big vertical over small vertical equals big horizontal over small horizontal. And this time I'm going to do algebra, which again we're going to learn later in equations, but I'm just going to teach you now. So we're going to times both sides by the thing below the variable. The thing below the variable is 12, so we times those sides by 12. And the only reason why we did this was to simply cross off these 12s. 12 divided by 12 is 1, therefore x equals, now I could take 4 and I could times it by 12 and I could get 48, then I could divide it by 6 and get, 4 times 12 is 48. I could divide it by 8 and get 6. But I'm going to do a process called cross-canceling. We're going to learn a little bit later in fractions. Now I can simply divide the top and bottom by 4, and 4 divided by 4 is 1, and 8 divided by 4 is 2, simply dividing the top and bottom by 4. And 1 times 12 is 12, divided by 2 is 6. X equals 6. So doing it over equals over is the same way as doing algebra multiplying both sides. We obviously could have done the lowest common denominator method, or we could have cross multiplied, which we will see a little bit later as well. Okay, so let's take a look at the next example in the notes. And we have a large rectangle and a small rectangle on the inside. Again, this isn't to scale, but the small one is 1 and the big one is 3, and the big one is x and the small one is 6, and I can do exactly the same method. So in the notes I've decided to do it a little bit differently, where in the last section I did one vertical over the other vertical, etc. Now I'm going to use the same shape. So I'm going to do vertical of the small shape over horizontal of the small shape. Now I just have to be respective. I did vertical, so it has to be vertical over horizontal. And then I can simply do a different method than I did before, no problem. Do top to top, bottom to bottom, etc. I'm going to do left to right. So in order to get from 1 to 3, I simply times by 3. And now I have to go in the opposite direction. So if I'm going the opposite direction, remember we want to do the opposite operation. So if I'm multiplying by 3 in one direction on the left, I have to divide by 3 in the other direction on the right. And I'm going to do a nice little lazy thing. 6 divided by 3, x equals 2. Makes sense. Excuse me. So we are now going to apply these exact same principles, like over equals over, due to the top, due to the bottom, due to the left, due to the right. Make sure you take into consideration direction. And we're going to do that either by over equals over. You can also do the lowest common denominator principle we did in the last video. You can do algebra multiplying both sides, etc. And we can apply these to all of the rest of the questions. So we can apply them to conversions. We can apply them to unit rates. We can apply them to equal ratios. We can apply them to scale ratios. So with these last two videos and notes on methods, we can apply these exactly the same methods to the remainder of the homework and many times again into the future.